All right, diving right in. Today, we're taking a close look at all the exciting stuff happening over at NASA. We've got a ton of updates from their YouTube channel and their website, and let me tell you, there's a lot to unpack. So, our mission, if you choose to accept it, is to sort through it all and bring you the most interesting and impactful news, stuff you really need to know. Ready to go.
Absolutely. It's amazing to see so much happening all at once, from low Earth orbit to the moon to galaxies billions of light years away. It's a really exciting time for space exploration.
It really is. So let's start with some good news a little closer to home. SpaceX Crew 9, they splashed down safely off the coast of Florida on March 18th.
Right.
That's NASA astronauts Nick Hague, Suni Williams, Butch Wilmore, and Roscosmos cosmonaut Alexander Gorbanov.
Yeah, they spent quite a while on the ISS.
They did, and they were busy up there conducting some really fascinating research. What were some of the things that really stood out to you?
Well, for me, what's remarkable is the sheer range of science happening on the ISS. I mean, they were exploring potential treatments for brain diseases like Alzheimer's, using these tiny lab-grown brains called organoids. It's incredible. They can study them in microgravity, which offers a really unique environment.
It's amazing how they're using the space environment to potentially help people here on Earth. And they were also working on improving how we make medicines in space, right?
Yeah.
Like with protein crystallization.
Exactly. The lack of gravity allows those drug crystals to form in ways we can't replicate down here. It's a game changer for pharmaceutical research.
It is. And it wasn't just astronauts doing science. There were student experiments, too.
Oh, yeah. Tons of those. Looking at everything from how bacteria grow differently in space to testing out that first wooden satellite, the Lignosat. Remember that?
Oh, yeah.
And they even collected microbes from outside the station.
Wow. So much science going on up there.
Over 150 experiments in over 900 hours.
Wow, that's a lot of science. They were even experimenting with 3D printing medical implants. It's like something straight out of science fiction.
Totally. And let's not forget the millions of Earth photos they took, helping us understand our planet better.
Right. It just shows how vital the ISS is as this incredible orbiting laboratory. So many disciplines benefiting from the research up there.
It really highlights the importance of microgravity research for sure.
Okay, now, for something that'll really blow your mind, the James Webb Space Telescope. It recently set its sights on the HR 8799 system, which is like 130 light years away,
Yeah.
and directly imaged multiple giant gas planets orbiting the star. What's more, it detected significant amounts of carbon dioxide in their atmospheres.
And this is huge. It's the first time we've directly observed CO2 in an exoplanet's atmosphere.
So that's a big deal then.
Oh, absolutely. This observation strongly supports the core accretion theory, which explains how giant planets like Jupiter and Saturn form. They start as a rocky core and gradually pull in gas and dust.
Yeah.
It helps us understand how planetary systems come together.
So this CO2 is like a piece of the puzzle then?
Exactly.
I see.
It's amazing what JWST can do. It uses a special instrument, a coronagraph, to block out the star's light so it could actually see these planets. It's like trying to spot a firefly next to a spotlight.
Talk about a challenge.
Wow. And even though these particular planets aren't habitable, being able to directly detect CO2 opens up incredible possibilities for finding it on planets that could support life.
It does. It makes you wonder what other secrets are out there just waiting to be discovered. I mean, as we find more of these building blocks of life on other worlds, it really begs the question, are we alone in the universe?
Big questions.
Huge question.
Bringing things a bit closer to home, NASA launched its EZE mission on March 14th. It's focused on studying Earth's auroral electrojets. Now, I know we've talked about auroras before, but what exactly are these electrojets? So think of them like electrical currents flowing high up in our atmosphere. They're actually what cause the auroras, those beautiful lights we see in the sky. EZIE stands for Auroral Electrojet Imaging Exploration, and it's a group of 3 small CubeSats flying in formation about 350 miles up. They're each equipped with a special instrument called a microwave electrojet magnetogram. It measures magnetic fields, and by studying the magnetic fields created by these electrojets, we can learn a lot about them.
That's fascinating. And why is it so important to study these electrojets?
Well, for one, they can impact space weather, which can disrupt satellites and even cause power outages here on Earth. By understanding them better, we can improve our space weather predictions and protect our technology.
So it's kind of like a space weather forecasting then.
Exactly.
Wow.
And the way these CubeSats are flying in this pearls on a string formation allows them to take really precise measurements. It's a clever way to study these phenomena at altitudes that are really hard to observe.
That makes sense. Yeah. Okay, now let's zoom out to the universe again. The Euclid mission, a collaboration between the European Space Agency and NASA, just released its first data on March 19th. This mission is on a mission to unravel the mysteries of dark matter and dark energy, two of the biggest puzzles in cosmology.
It is, and what's mind-blowing is the sheer scale of this project.
Hmm.
Euclid is going to create a 3D map of billions of galaxies. It's just, wow. And NASA played a key role by providing the detectors for one of its main instruments. And get this, the initial data release alone contains observations of 26 million galaxies, some over 10.5 billion light years away.
Well, 26 million, that's incredible.
I know, right?
And they're just getting started.
Right. Over its 6-year mission, Euclid is expected to observe over 1.5 billion galaxies. It's going to measure their shapes and how much their light has been stretched, what we call redshift, which tells us how far away they are and how fast they're moving. All this data will give us an unprecedented view of the universe's large-scale structure and how dark energy is driving its expansion.
So it's like creating a giant map of the universe.
Basically.
Wow, that's amazing. And to think, this mission complements NASA's upcoming Nancy Grace Roman Space Telescope, so we're going to have even more data to help us understand these cosmic mysteries.
It's a great time to be a cosmologist.
All right, let's shift our focus back to our own solar system for a moment. NASA's Lucy mission has a busy year ahead. It's set to fly by a small asteroid named Donald Johanson on April 20th.
Yes. Now, this flyby is mostly a test run for Lucy's navigation system before it heads off to explore the Jupiter-Trojan asteroids, these ancient relics from the early solar system. But Donald Johanson itself is pretty interesting. It's about 3 miles across and rotates incredibly slowly, possibly due to how sunlight is affecting it.
Huh, that's weird.
It is. Scientists think it might have broken off from a larger asteroid about 150 million years ago. This flyby will help them confirm if it belongs to a family of asteroids called the Aragon family.
So it's like a little pit stop on Lucy's grand tour of the Trojan asteroids. And by the way, love the name Donald Johanson.
Yeah. It's named after the paleoanthropologist who discovered the famous Lucy fossil, one of our early human ancestors.
I love that. It's a nice connection to our own origins.
It shows how interconnected all these missions are. They all contribute to our understanding of the cosmos and where we fit in.
Absolutely. All right, last but certainly not least, we've got some history-making news. Firefly Aerospace's Blue Ghost mission successfully landed on the moon on March 2nd. And this was the first fully successful commercial moon landing, a huge milestone for space exploration.
A huge milestone indeed. Blue Ghost touched down in the Mare Crisium Basin and spent about 2 weeks on the lunar surface, delivering 10 NASA science and technology payloads as part of the Commercial Lunar Payload Services, or CLPS, initiative.
That's fantastic. And those payloads conducted some groundbreaking experiments, right? Like they drilled deeper than ever before with a robotic thermal probe, and they even managed to acquire the first GPS-like signals on the moon.
Exactly. They also tested technologies to deal with lunar dust, which can be a real problem for equipment, and a radiation-tolerant computer, which is crucial for long-duration missions. And the images and videos Blue Ghost sent back were just breathtaking. Lunar eclipses, sunsets, just incredible.
Oh, I saw those. They were stunning.
The mission transmitted a huge amount of data back to Earth, exceeding all expectations. This really demonstrates the potential of commercial partners to contribute to lunar science and exploration. It's a game changer.
It is. It's amazing to see what's possible when innovation and collaboration come together. Wow, what an incredible time for space exploration. From the ISS to the moon and the farthest reaches of the universe, NASA and its partners are pushing the boundaries of what we know and what we can achieve.
Absolutely. And for me, the biggest takeaway is the growing role of international collaboration and commercial partnerships. These are the trends that are going to shape the future of space exploration.
No doubt about it. So, as we wrap up, I want to leave you with a question to ponder. As space becomes more accessible through commercial ventures and these global partnerships, how might that change our understanding of humanity's place in the cosmos? And what about the resources that might be available to us out there? What new discoveries or applications might we see in the future thanks to these advancements? It's an exciting time to be alive, and I can't wait to see what the future holds for space exploration.